Okay, okay. Yeah. Okay, what is this Tobit model? It's a sensor model. Okay, it's a sensor model. Uh, they have explained one good instance where sensor model can be applied. As I told you, there are two types of models, right, with limited dependent variables, right. One is the sensor model, the other one is truncated models, right. Uh, there are occasions in which you won't be able to get data, right, from some people, right. So you'll ignore. For example, right, number of hours worked, right, is taken as a model, right. What are the factors that determine people working, right? Number of hours they are willing to commit per day, right? If you want to study that, right, you will be collecting data for data with all the people, right? You have to collect data from all the eligible persons in the labor group. But if you go there, right, you won't go to the people who are unemployed, right? Who are committing to employment. They are not committing. Actually, they are unemployed. Right? You won't be able to go to them and collect data, right? So you will ignore people who are unemployed. Similarly, the people how much amount have you spent on car, right? If you ask that question, you will only tend to go to only people who are owning the car, right? No point in going to this people. But if you do that, right, some it's about the degree, right? Maybe the factors leading up to this even have some negative values, or it will start from some threshold value, right? So below it you will tend to eliminate on a own, right? So those samples can be analyzed with truncated models, right? So those samples can be analyzed with truncated models, right? Specifically, it will have a very different functional specification. It is a two-stage Heckman's procedure that can handle all these things, right? But in our case, ours is a single equation model. Actually, Tobit model is a single equation model, right? Here, the situation is not about truncating; it is about censoring, right? For example, people who got scored, right, centum, right, you cannot give them more mark beyond 100, right? They may have the ability, but you rank them as 100, even to the people who have gone beyond 100, right? So if you take the samples, right, all samples will be sometimes, right, the threshold value, you'll have a lot of observations, right? It is not correctly measuring the ability of the individuals, right? So all are bunched together. You are taking all the samples, but all the bunched values does not represent a single value, right? It has multiple values in it. It is not coming to the fore, right? Beyond the threshold value, right? All the values are bunched into one, right? So this is a situation where you are taking the samples, but it was not representing the same value, right? All hundreds are not same, right? Some people may have the ability to score even 100, 200, 300, right? Right? So those people are also there. So thus that kind of data is analyzed with this censored models, right? Tobit model is such model. If you take them all as one single value, right? Naturally, you will get the biased regression coefficient, right? To avoid that bias, right? This Tobit model is used. Otherwise, it is a normal regression model, right? We are trying to address the problem of bias, right? With some special procedures, right? Okay, this is not a wireless model. This is a uh, uh, MLE model, right? Maximum likelihood estimation model, right? So non-linear regression model, right? So we are going to take one case here. So I've given the data, Tobit data, right? We can open the data, and the data will be like this, right? The data will be like this. I'm not actually going to run this GG plot. This is a GG plot. I'm going to run it, and if you run the plot, it will look like this, right? Just look at that. Maximum score. Actually, here 800 is a maximum score, right? Some aptitude, academic aptitude test, APT, is taken, right? The maximum is 200, 800, right? All the values are bunched, right? Many values are bunched in that. So consider the situation in which we have measure of academic aptitude scaled 200 to 800, right? Using the reading maths scores, right? So again, here we have one factor variable also, right? The academic, general, and vocational program. People are coming from different streams, right? Answer all the questions in the academic aptitude test correctly, receive score 800, even though it is likely that these students are not truly equal in aptitude, right? The aptitude you are measuring, right, is not the numbers, right? It can measure, but this is not the full representation of the aptitude, right? So with this understanding in mind, we are running this model. So this is a truncated, censored model. Beyond 800, we don't have any observations, right? So otherwise, it is not censored to the left, right? Sometimes you will have censored to the left models are also there, censored to the right models are also there. Otherwise, it's a single equation model. We are trying to assess the aptitude as a function of, right, maths and reading scores with the streams they belong, right? So this is what we are trying to do, right? If it is a factor variable, naturally this is a ANCOVA model, right? Because one factor variable is there, remaining them are scaled variables. These mixed variable regressions are otherwise known as ANCOVA model. That can be run. That can be run with, or I have sent the code already. So this is the code. Okay. Sorry. Tobit model. Tobit model is run with using VGLM from VGAM package. Package is VGAM, right? This is the package, and this is the function, right? Actually, this is the function. This is the function, right? So Tobit run is run with VGAM package, right? Function is VGLM, right? Now I am going to read this data first. I am going to run this data. Yes, this is the Tobit model. First, I am going to load the package VGAM. I have already installed it. I am just now loading it. Okay, to run this, I have to load these these packages, right? What are all the packages that I should run? First, I should. This is the error it's showing, right? To run this package, it requires LR test and logit. Sorry, package, LM test and package car. Both has to be loaded. How would I load? Library. Library LM test. Library car. Finished. So I'll just paste it before this. Only then it will not show any error. It requires only these three. Now let me run this. Let me load these three packages together. Done. No errors, right? It's okay. It is accepting. Now let us read the data. Okay. Data is read. Right? If you want to see the data, you can see it. It is reading the data. Right?
So its model is amplitude values are truncated by each other.
Yes. Not truncated, censored. Truncation is a sample problem. Right? Censoring is not the sample problem.
The issue in the population itself.
Yes. Okay. Now let me run this model. Yes, it is run. Now let me get the summary of this one. Right? See, what is the thing we gave? Like, in any other regression model. Right? Like in any other regression model, we gave this as a dependent variable, right? And some independent variables. And we give some specification for Tobit, right? Tobit, right? We have to tell the censor value, right? Where the value is censored, right? It is censored at 800, right? Otherwise, it was very same. Nothing very strange about this function, right? Usual regression function plus Tobit censoring specification. That's it.
One is that third exponential value. The first exponential value is readability. The model.
Program. Which program do they belong? Which program do they belong?
Readability, mathability, and
Program.
program.
This one. vocational, general.
Okay.
Okay.
Fine. So we got the summary results.
Yeah.
Please do that upper as 400. Let's see. Can be censored by 400.
Yeah.
So please run that also. Then we can make a comparison.
Yeah, we will do it. We'll do it. First, let us interpret. Then, we'll go there. Let's look at this.
Can you take the screenshot? A slide portion list.
Yeah. This interpret actually intercept 1, 2 has got different meaning. Actually, I'll just send you the document. I can read it. But we can see the aptitude, right, increases by 1 unit, right? The aptitude on an average, the aptitude score increases. The aptitude increases by 2.69 units for every increase in for every unit increase in reading score, right? Similarly, the aptitude increases by 5.9 unit for every increase in math score, for every unit increase in math score. So math scores are very important than reading score. That's what it says, right? Compared to the academic stream, right? Professional general stream. No, this is an ANOVA thing, right? Actually, this is a score, mean score difference, right? On an average, the general course is 12 point lesser than
Average.
the average academic stream people, right? And the vocational stream people has got scoring 46 unit less than the compared group, right? That's what it says, right? So this is the interpretation of ANCOVA and ANOVA type models, right? So this is a mean difference, right? Mean difference. They are scoring less than the floor group, the base group, right? So this is how it should be interpreted. The coefficients, this general group is not so different from the academic group. That's what it says. Because it is not significant. It is not significant, mind you. This is not significant. Right? So, though it is showing minus 12, it is not significant. It is not significant. So, you need not have to interpret that. All the other variables are significant at 5% level. Right? This is how it should be interpreted. Right? So, otherwise, this is like a OLS only. This is like a OLS only, but it is MLE correcting for the bias in the sensor, right? As actually I have not tested. Let me check. If I put 400, what would I get? Let me put 400 here. Let me see what happens. I'm also equally excited. Yeah, they are getting different results, right? Okay. So it has to be explored. That tools have.
Can you please compare it with the previous one, the results? The 400 results.
No, we can compare that with OLS, ordinary least squares, right?
That also we can take. So compare with the 800 400.
No, yeah, some of the results it was not showing. Mind you, actually see. Did you see that? Some of the values are not available. It is saying.
Oh, if you censor by 400.
Yeah. I know the theoretical implication of it, right?
Then can you please show the result? Just for the sake of it.
Yeah.
Topic model is to consider suppose no idea. ഒരു value ഇല്ല നമ്മൾ 800 180 മുൻപ് സെൻസർ ചെയ്യുക ഇത് 400 സെൻസർ ചെയ്ത് കഴിഞ്ഞിട്ട് അപ്പോൾ അത് നോർമൽ റിഡക്ഷൻ ചെയ്യാൻ പറ്റില്ല നോർമൽ റിഡക്ഷൻ ചെയ്യാൻ നോർമൽ റിഡക്ഷൻ ചെയ്യാൻ ഫുൾ സ്റ്റേറ്റ് വാല്യൂസ് ഇതിന്റെ ആശയങ്ങൾ ഉണ്ടാവും അതായത് നമുക്ക് വെറുതെ ആ നമ്പർ മാറ്റി ചെയ്യാൻ നമുക്ക് ആവശ്യമുള്ള ചെയ്യാം പക്ഷെ അവിടെ
You can compare.
So no way, no coefficient, and no variable is significant.
I know why does it so actually because this z value, right, like t value only, right? I'm not getting why is it not giving this value.
You can then can we take the descriptives of both these censored samples?
No, it is there. No, it is there.
Descriptive is there.
No descriptive is there. Actually, we will check it. Actually, we'll see the thing. I'm not able to understand why this z value is 0, despite we are having the coefficient value and the error value there. Standard error is there. This estimated value is there, right? I'm not able to understand why this z value is not available.
The key value.
Like t value only, no? You should get it. Actually, if you get both, right? What is the point? You are not able to get this value. We have to check it. Actually, let me. It requires further expression, right? Fine. Okay. So it is like your ordinary least squares only. Now we can check with ordinary least squares. The same can be run with ordinary least squares. Alum. We can put this on. DF. In the data frame is DF. Summary model 1. This is wireless. Now we can compare, right? This is wireless result. Read coefficient 2.69. Here 2.55.
Not much difference.
Yeah. But there is a difference. Not much, but there is a difference, right? We can see the consistency. Actually, suddenly I'm
The problem is that consistency.
consistency.
Awareness may not be consistent.
Yes, right. So this is the problem, right? And significance also no, the same, no, almost same.
Significance also same.
Ah. T value is little different, but almost same.
Almost same.
Yeah. Right? Okay.
Because the result is given. Some same ആണ്. Just a problem. Awareness function equal. Topic function equal almost we are getting the same value. That's the problem. We cannot run awareness. We cannot run awareness.
For a censored data set, you should not run OLS. Right? Okay. So this is what is about our Tobit model. Right? Actually, we can now move on to the simultaneous equations model. Right? Simultaneous equation models have got a lot of problems. Right? A lot of problems. Actually, we are doing a very simplest of the things. Right? So we all know simultaneous equation models are simultaneous models, right? It is about identification. Actually, you will have a lot of problems about identification, right? In simultaneous equation models, the same models, same equations can be represented in multiple ways, right? So if the same thing can be represented in multiple forms, if the results are the same, no problem, right? If the results are not the same, right, then we'll say the problem of identification exists, right? Whatever equation, the first equation can be transformed into the second equation. Second equation can be transformed into first equation, right? We should get the consistent results, right? What you get in the first has to be got in the second also, right? If you get different results for different forms, right, then you will have the trouble of choosing between the two, right? This problem is known as identification problem, right? You have to choose between them, right? So this is not the right thing, right? Actually, you must get only one answer for the mathematical problem. If 2 plus 2, 2 plus 3 is 5, right? Even 3 plus 2 is 5, right? It cannot be different, right? So such problems are known as identification problem, right? We have to thoroughly check them, right, before running a model. If it is having a problem, right, there are some cures for it, right? There are cures for rectifying the problem of identification, right? So I'm reducing it to the problem of estimation, right? I am not discussing those issues here. I'm just discussing only one issue, right? What is the issue? The issue of simultaneity bias. Simultaneity bias, right? Again, if you have multiple equations, right, you will actually you will have the problem of two-way causation. You will have the problem of two-way causation, right? In multiple simultaneous equations, you cannot clearly say dependent and independent, right? What is dependent in first equation will become independent in the second equation, right? So they will say there the terminology in the simultaneous equation models will change, right? You cannot use the term dependent and independent. In simultaneous equation models, you have to use the terms like exogenous and endogenous regressions, right? Exogenous and endogenous variables, right? Of course, character-wise, they can be compared, right? Dependent variable can be compared with exogenous variables. Independent variables can be compared with exogenous variables, right? But they are not the same, right? Equation to equation, it will change, right? So this terminology is used, right? So exogenous variables are determined outside the model, endogenous variables are determined inside the model, right? So that is the broad definition of exogenous and endogenous variables, right? Because of this problem, the endogeneity, because of this problem of endogeneity, right, you will have the problem of simultaneity bias, right? You will have the bias in the estimation, right? The sample size cannot solve the problem of consistency and bias, right? So we have to address the issue of this simultaneity bias in the simultaneous equation models, right? For that, we cannot, for that reason only, we cannot apply OLS straight away. Right? What do you mean by OLS, applying OLS? Right? Applying OLS separately. Right? Applying OLS method separately for equations will not work out, because you will have the system, in the system you will have the problem of simultaneity bias, and so single equation methods will not work out, right? So single equation method here is usually OLS. This OLS method cannot be applied straight away, right, in the simultaneous equations thing. So usually there are two sets of solutions available. One is single equation estimation. Another one is system equation estimation, system wide estimations, right? Single equation estimation, right? There are many. The prominent among them are, one is indirect least squares, the other one is two-stage least squares, right? Or instrumental variable method, right? So limited information, LIML method, right? LIML, limited information maximum likelihood method, right? These are the four methods people quite often use, right? Some mixed methods are also there, but these are the prominent methods, right? In the system-wide method, right, you have two: full information maximum likelihood method, right, FIML, and 3SLS, three-stage least squares method, right? So these are the available methods, right? All have some advantages and disadvantages. Usually, the single equation methods are preferred because they are easy to calculate. If the single equation method is actually an extended OLS, that will also be good. This 2SLS is the two-stage least squares method, two-stage OLS, right? Otherwise known as two-stage OLS, right? So two-stage OLS method or two-stage least square method is a very prominent method, simple, and this effectively addresses the problem of simultaneity bias, right? This is the prominent method, right? Another OLS method, right, extended OLS method is three-stage least squares method, right? At three stages, least square methods are applied, right? I don't want to go into the academic discussions about it, right? All can be run with R. R can run this thing, and it requires some special packages, right? I'll just show the packages required. This estimation procedure, this the estimation of 2SLS and 3SLS, right, is available in the function system fit. System fit is the function, and this function is available in the package system fit, right? So system fit is the package name and the function name, right? So to run this two-stage least squares and three-stage least squares, we use the system fit function in the system fit package, right? Okay. Apart from it, it requires some libraries, some dependent packages, right? The packages are matrix, car data, LM test, zoo, right? These additional packages are required to run this regression, right? Okay. So Let me run it. Actually, let me first take the data. This data is, yes, SEM1, all capital SEM, structural equation model, SEM1, and I have taken data from Gujarati. For this, I have taken data from Gujarati. There is a good discussion about this. This is a market model, right? Market a supply function and demand function is given, right? With this, the simultaneous equation model is constructed, and I have taken. Let me show you the data. So demand and supply function. So quantity will be there, demand, this price will be there, and one more variable is there in that. I'll just show. Price, quantity, and let me see what it is like. Personal consumption expenditure, proxy for income. X is a personal consumption expenditure or income, right? Proxy for income. Q, quantity demanded or supplied. P, price, and X is the personal consumption expenditure. Three variables, right? It is there in the Gujarati textbook, right? Change it. Actually, see, I'll then I'll resend it because some problem exists. I'll resend it. Don't worry. Actually, I'll resend it. Don't use that data. Sometimes morning we had this hiccup. The reason was sometimes if we copy the data from PDF, sometimes some white spaces are also coming in, right? If any white space come into the values, naturally those values will be taken as a text, not as a numeric value, right? In that case, with numeric values, so with the text values, you won't be able to run the regression. So it was showing error, right? It was very frustrating. So I was using multiple things to get the problem right. So now also I removed one important problem is the comma, right? We'll use some comma separations, right? So thousands, right? Every first three digit we'll put a comma, right? Afterwards, for every two digit, we'll put comma, right? Those commas should not be included. Right? Actually, that sometimes it will take as a text. So I just removed it. Now I am sending that data file to you. The data is sent. You may use this data, right? I have sent the data. And this is the data, right? So this data will be taken into the R. Before going into this, let me clear off all the working files, right? Actually, that will always be good. How would you do it? Remove RM list is equal to ls. Yes, it is done. Now I am taking this data into R. To confirm it, I am just putting data 1. Data is there, right? Data has gone into R, right? You have the code now? Do you have the code? Not yet? Or else I'll just send. Okay, this data also have. This code also I'll send. Do you have the code? Okay, okay. So you have it, you have it. Actually, I've sent it, right? Fine. Now, this is the Gujarati data. Gujarati data. Yeah. You can check it actually. In fact, I can show you, right? I can compare the results. OLS and 2SLS. The results can be compared. So how would you define the variable, actually equation into R? It's very simple, right? Just look at this. This is the first equation. I'll show you in the textbook also that you can see that. Yes. It is in chapter 20. Yes, this is the data, right? This is the data, right? Oh, sorry. Not this one. Sorry, sorry. So index of production, prices fine. Correct only. Quantity, price, this is the model. This is the model. Okay. So this is the model we are running, right, with R. Okay, so I have defined this equation. First equation, right, only the stochastic equations have to be specified. Identities have to be removed. All the identity variables, identity equations have to be removed. Only the stochastic variables have to be included. Just look at that. First equation, Q is equal to alpha 0 plus alpha 1, P1 plus alpha 2x, xt plus u1t, right? So two variables, P and x, right? So the first equation, Q tilde P plus x, right? Two independent variables. So second equation, Q on P only, right? So Q tilde P, finished. So two equations are specified, right? We'll move on to the next one. We can club them into system, right, with list function, right? Two equations can be clubbed together. After defining it separately, we can club them together. And if it is no single equation method, you can use single equations also. But you have to specify which method are you using. So fit 1 is the system estimation function, estimation function in the simultaneous equations model, right? You have to specify which method you are using. I am using 2SLS, right? Another important thing is you have to mention the exogenous variables. Exogenous variables are taken as the instrumental variables in the simultaneous equations model, right? You have to mention it. What are all the variables, right? You take it as exogenous, right? They have to be specified. Here only one exogenous, P and Q are determined inside the model. In the market model, price and the equilibrium price and equilibrium quantity is determined inside the model. They are endogenous. What is left out is income in the market model, right? So that X is exogenous. So inst is the specification. Okay, this is how we are specifying, right? 2SLS, instrumental variable is X, right? If it is multiple variables, right, you can put plus, right? You can separate and you can give as many instrumental variables as possible. You can give, right? Data set is there. Now I am running this regression model. I am running this estimation. Okay. Now you run. You can I want to compare this result with OLS model, right? So I am just running the OLS model also for the same. For the equation 2, I am running the OLS also. Now I can compare the 2SLS with OLS. Yes, both the results have come, right? We can compare, right? First, we can check whether it is confirming with the book result. Then, we can take the book result and explain. This is OLS, right? This is OLS result. This is OLS result. We can compare this with 2SLS result. Okay? Shall we move on? Two SLS results are also there. Fit one, is this 2SLS thing. This is a 2SLS result. We can compare. Before getting into this, we can compare this with the book result. This is OLS result. This is OLS result, right? This is the OLS result. We can compare. Compare this. OLS 65.1719, 17187, right? So you can compare this and this. Standard error, right? And this is the coefficient of P, 3272. Standard error 0834, 0835, and T values and P values, corresponding P values. So this is OLS. Similarly, you can compare the 2SLS result also. Here they have used ILS, indirect least squares, right? If they are perfectly identified, right, exactly identified, this ILS and 2SLS is the same, right? That is the theory. You can compare that result also. You can compare now. Indirect least squares, you can compare. Right? The reason for showing is this, that you can compare the discussion. Actually, you can read in the book to understand more about this issue. Right? So what we are generally getting to know is that the results of OLS and the 2SLS is different, right? The values are very different, right? So the difference is due to the problem of simultaneity bias, right? The result is due to the problem of simultaneity bias, right? In fact, it can be run with 3SLS also, right? That also can be done. So one more step, you are going to run the third fit 3. Everything remains the same except the method. It is done again. We can get the summary of fit 3 also. Fit 3. We can run it. It looks very similar to 2SLS. Looks very similar to 2SLS. Actually, we can take it and then we can compare. Looks very similar to 3SLS. Looks very similar to 3SLS. To compare this, to compare the consistency, right, we can use Hausmann test. Right? The results of 2 can be compared with Hausmann test. that is available in the Hausmann dot system fit function. Hausmann dot system fit function. Hausmann dot system fit function. We can run it and you can get the results. Some error is showing. Hausmann. How do you solve this problem? I've taken function from this only. Oh, the result has come. So it's running. Fit 1, fit 3. Some errors. Some error is there. I don't know. We'll correct. We'll make use of. Okay, so some error is coming. Actually, otherwise, I've said the same function, but there is a problem. Okay, so we'll stop here, right? This test is supposed to give us the fit, right? The comparison between the 3SLS and 2SLS model, right? If the result is insignificant, we can say both the models are same. If it is significant, we'll say the models are different. In that case, right, 3SLS is not consistent with 2SLS model. Usually, the better model is 3SLS always, right? So we'll take the 3SLS results, right? If they are not same, that means 3SLS is different and 3SLS has to be taken, right? If it is same, right, no problem. You can take 2SLS without any trouble, right? So this is what is simultaneous equations are about, right? Okay, we'll stop here and we'll discuss about certain general issues, right? Right. Santosh asked me to talk about certain general issues that we promised in our course. What is the issues that requires some discussion? We'll take the syllabus. Yes, it is there. It can be estimated, the sure model can also be estimated. So the method is sure, SURE, right? So that is not the issue. Okay, fine. Splicing, right? And time series models, right? Actually, I've told not possible to cover this time. When model adequacy we have already covered, so we'll talk about these issues, right? Splicing, deflation, right, and structural breaks. Okay. You take one series, okay? This is the price index. This is the price index, right? All commodities and primary articles, food articles, non-food articles, right? Consumer price index,